Hello everyone, this is Sam from HiPy. Today we're going to be learning about the basic building blocks for data in Python. It's Numpy and Pandas. Get used to them. You might not like them, but tough. We just got to get used to them because they are the most important part of Python for data. They are the data structures that we are going to be working with during our time learning about data in Python. So the first two things we're going to need to do is import our libraries. We have Numpy as NP and Pandas as PD. So those are kind of like the standard things that I'm going to be using during these guides. So feel free to do that if you want, but obviously if you don't want to for some reason, then that's fine. So what are Numpy Arrays? Because they are the basic building blocks. Numpy Arrays are just a nicer way for the program or for your computer to kind of interpret lists that's faster and gives us a little bit more kind of like options about what to do with these. So if we do np.array1234 in our list and we print a back, we just get a normal list. But what we can do here is it just runs a lot faster, basically. Python's a language that compiles down to C, which is a low-level programming language, and behind the scenes, Numpy does a lot of work in order to optimize these lists so they are faster than Python lists. And a lot of the functionality that happens in Python lists carries on to Numpy lists. So, for example, you can iterate over them, you can kind of add them together, you can do loads of different things, and there's actually more functionality that you can get from them. For example, if I give you the a squared, it actually just gives us the kind of list of all the values of a squared, whereas if I do 1 2 3 4 squared in normal Python, we're just going to get an error back because it doesn't know what to do. But Numpy's really nice in the way that we can perform simple operations to the entire Numpy array and it'll understand straight away what's going on. And then Numpy also lets us create multi-dimensional arrays. So for example, np.array and then it's square brackets, so 1 2 and then 3 4 will give us the Numpy array of this very simple matrix. So I'm going to very quickly clean up my code here. Print B. We'll see 1 2 3 4, and then this is really useful for the maths nerds like me who want to do linear algebra, who want to kind of do all the kind of boring, messy stuff in Python. I mean, it is fun for us, but that's for another video. So those are some nice and simple arrays. Numpy also has some interesting ones that we can look at. So we can create a array just made up of all ones. If we do np.ones and then we run the tuple of the kind of size and the dimensions that we want to be doing. So if I print C now, we'll see C is just going to be loads of ones, and we can do the same with zeros. It might be just without the E here. There we go, it's zeros. And they're kind of just really helpful to know because sometimes your data will just need like a load of zeros and you can just quickly use it using Numpy arrays. So the other module we're going to be looking at today, and perhaps the more useful to us directly, is Pandas. So Pandas is concerned with two objects. One is the series object, and the capital letter on S does matter here, which is a little bit annoying, but what can you do? And the series, it just takes in a list, so like a Numpy array. So for example, I'm going to reuse the one that I had earlier. So if I just say A, and then we will get back it's D that we want to print out, not A. We'll get back kind of like a table here. And what's important to know is in a lot of the programs, I think the Spider console is the Spider script editor is the only one that doesn't let you do this. We work in is that if you just pass D into one of the cells, you will actually get just the series or data frame back out as an output instead of just kind of like a printed process. So I'm going to be abusing this in this guide just to save me from kind of typing print all the time, but I am consistent in the written resources for print. But just know that especially with data frames, you can get a really nice formatting back by just returning the data frame and not just kind of printing it. So speaking of data frames, we're going to look at data frames. We're going to say E is equal to pd.dataframe. And then we can do it by two ways. We can either use a dictionary to list all the columns, or we can use a multi-dimensional Numpy array. So we'll go over both. So the first one I'm going to do is I'm just going to say A is going to be the list 1 2 3. In fact, I'm going to be a bit clever here. I'm going to say A is equal to our Numpy list up here. And then we're going to go through and we're going to say, so that's A, and we're going to go comma. We have B is going to be equal to A plus 2, comma. C is going to be equal to A plus 3, 4, let's make it 4, why not? And D is going to be equal to A plus 6. So we have this. And then if we print E, we'll see at the very start we have this nice little grid, but if we do just E, we get this super nicely formatted grid where we can highlight different rows and just look at things in a much nicer formatted way. So if you're working by yourself, I'd encourage you to do this. I keep on printing it just for consistency in the written guides, but this is a really nice thing that I do when no one's looking. When I'm at home alone, I just leave out the print, and you're not really supposed to do that, but why not? We'll do it here. So the other thing you can do with dictionaries is, data frames, is you can pass a multi-dimensional Numpy array. So I'm going to be using the random kind of Numpy sub-library here, and the rand_n to pass through a Numpy multi-dimensional array, which is going to be 6 by 4. So if we do this, and then we just return F, we see here that we now have a 6 by 4 Numpy array of just random numbers. So it's kind of like a neat little shortcut that you can do just to save time. So in the worked example for today, now that we have looked over all of this stuff, we are going to be looking at more detail the random number generators in Numpy. So Numpy has a lot of random number generators, and I use these a lot of the time to for example, for machine learning, I use it to test out the algorithms. It's a really nice way of kind of faking data for yourself to practice things. You kind of need a little bit of kind of problem solving to get the data how you want it to be, but it's a really useful kind of way of doing things just to quickly get things going. So what we're going to do is we're going to quickly create a data frame called MyData. My data, that's interesting. MyData, which is going to be a pd.dataframe, which has a dictionary, and we're going to say the column name is going to be random numbers, and we're going to say this is going to be np.random.randn, and then we're going to give it 100,000. That's 100,000, yeah. So we're going to go enter. Pandas has no enter, yeah, because the capital letters, fantastic. Okay, so and then if we just give MyData.head, this is a method which just returns the top 5. So we can see we have 2.18, and we have a load of different random numbers here, which look like they're kind of centered around 0 in some way. We have some above 0, some below 0, so my initial guess is that these are going to be centered around 0. But of course we don't like guessing, so what we're going to do is we're going to say MyData.describe, and then if we press Shift Enter, we get a load of different summary statistics about our data. So we can see the mean here is minus 0.001, which is really close to 0. Our standard deviation is 1.003, which is super close to 1. So you might be thinking, if you're a mathematician like me, this looks awfully like the standard normal distribution, and if we see numbers kind of out in the tails like a 2.18, that could be true. And what we can actually do here, just to confirm this is just kind of for anyone interested in the kind of statistics behind this, is we can import our matplotlib library, then we can sort our data. So this is using the MyData. MyData is large here, .sort_values, and then by 0, I think this might work, I might have to change this, x equals lin, np.linspace, so np.linspace will set up a dummy kind of like array, which is going to have 100,000 elements in, which we're just going to use to kind of plot it against. So it's that kind of array only exists for us to kind of plot the data against. It's just counting from -10 to 10. You can go from 0 to 20 if you wanted, I guess, or from 0 to 10, and the graph will look exactly the same. And then if we just go plt.show, we will get, yep, I was kind of expecting this. MyData.sort values, let's go back down here, Kiera is 0. I think we're going to be wanting to use the random numbers here. So there's a little bit of a kind of like a a common thing in Python, where in Pandas, where sometimes you have to do the axis. So the axis by 0 is columns and 1 is rows. So that's why I got a little bit confused there. But hey, we all learn something sometimes, I guess. So what the sort values function does is it sorts by the column that you input. So we have all of our data now, and then we're just sorting it from we're sorting it from the lowest to the highest, and then we're going to just graph the data. So here we can see we have our lowest data here at like less than -4, and then we have our highest data here at greater than -4. And you can see this really nice smooth line that, a lot of the statistics nerds out there like me will say, this is just the distribution function for the normal distribution. Well, hey, so we can now say, yeah, this is the normal distribution. And in fact, if you look at the documentation, you can see that the rand_n function, the n stands for normal. If we did exactly the same thing, and instead of n we just say rand, we can just do this, and we can go shift enter, shift enter, shift enter, and we can see it's now a straight line, and the actual result that comes out here is a uniform distribution. So we have an equal chance of getting everything from 0 to 1. So my challenge to you here, in the written resources, we have a subject list and a data frame that has the marks for a load of different students here, going from like A to W, and we want you to find a load of different data kind of points and statistics about this. So the average mark for English, each student's average mark, which students scored the least marks in, the student who got the most in the class overall, and just get really comfortable with using the data frame object and manipulating data. So if this was a little bit complicated, it's fine. Just keep it slow. Don't worry. Don't worry about kind of like accessing the Pandas documentation online, because that's really helpful as well. But just most importantly, take it really slow and make sure you understand all this, because it's super duper important. And more importantly, have fun with this. Just perhaps it's not very interesting at the moment, but later on we'll see kind of some of the fun things you can do, and it requires you to know all this stuff like inside and out. So I'll see you then.